I first tested the Cloud RO system back in 2024 on municipal water in Denver, Colorado. And now I recently retested it on a much more contaminated municipal water source to see how well it holds up. So in this video, I'll walk you through the new test data, including independent lab results from two completely different water supplies, hands-on testing of things like flow rate, efficiency ratio, recovery rate, and TDS Creep, and I'll show you exactly how Cloud RO earned an overall 9.24 in my data-driven scoring system. Cloud RO is a tank-based under-sink reverse osmosis system, but way more modern. Instead of the bulky multi-sump and filter setup you see with most conventional ROs, Cloud packages all 4 filtration stages into a single removable cassette, which the company calls the magazine, and pairs that with a compact 3.2 gallon pressure tank that stacks behind the unit, internal sensors that track filter life and water usage, a mobile app, and a built-in remineralization filter. This is the best system for folks who want the proven reliability of a tank-based RO design, but with the user experience and smart features you'd expect from a more modern premium product. At the time of recording, Cloud RO runs about $550 at full price, which puts it on the higher end for a tank-based under-sink system. But for any water filter, it's just as important to factor in and calculate its long-term cost. Based on the filter replacement schedule, I calculated an ongoing cost of around 18 cents per gallon, which works out to roughly $200 per year or $1,600 over a 5-year ownership period, including the upfront purchase. Filter lifespan depends on the specific water quality and frequency of usage, so your actual cost may vary. After installing the Cloud RO, I put it through a battery of tests I now run on every RO system. That includes things like flow rate, efficiency ratio, recovery rate, TDS creep, noise output, and a booster pump test to see how feed pressure affects performance. And the big one, of course, is its ability to reduce and remove contaminants, which I measured by sending pre-filter and post-filter water samples to my lab partner, TapScore, for independent analysis. And so if you appreciate this kind of data-driven testing, give this video a like to let me know I should keep testing RO systems like this. And let me know in the comments which RO system I should test next. Installation and how easy it is to set up is one way that Cloud RO stands out from other conventional under-sink reverse osmosis systems. My install took just 45 minutes, which is the fastest install time of any conventional RO I've tested. Now, part of that fast install time is because I already had an existing hole in my countertop for the dedicated faucet, and I used a disposal drain line adapter instead of drilling a separate hole in the sink drain. Both of these things made the install process a lot easier, and you can repurpose an existing soap dispenser hole in your countertop or your sink if you have one. Also, I'll link to the drain adapter I used in the description, which I definitely recommend instead of drilling into your drain. Beyond that, Cloud's design itself is really what makes things faster. The filter magazine already has all 4 filters loaded inside. Each tube is clearly labeled and comes with elbow connectors already attached, so you just plug them into the corresponding port on the base. The drain saddle comes pre-installed on the tubing if you're going to use that. The 3-way cold water shutoff is stainless steel with a 1/4-inch quick connect for the tubing. And the magazine is detachable from the main body of the unit, so you can easily place the base alone and then attach the magazine once you're done working under the sink. I counted 14 potential leak points, which is lower than most other conventional ROs I've installed. And another nice benefit is that Cloud doesn't need to be plugged into a power outlet. The internal sensors are powered by a built-in battery pack, so you don't have to worry about using or rewiring a switched outlet. After installation, I followed Cloud's flushing instructions, which involved filling and emptying 3 full tanks of water. That took about 6 hours and 15 minutes of mostly hands-off flushing until the system was ready for first use. Cloud rates the system for up to 80 gallons per day, which is on the higher end for a conventional tank-based RO. I timed how long it took the system to fill 12 ounces of purified water, recording the process on camera so I could measure frame by frame for precise timing, and I did this 3 times. At a feed water temperature of 55.7 degrees Fahrenheit and a static water pressure of 50 psi, the average fill time across 3 tests was 124.29 seconds. That works out to a flow rate of 0.05 gallons per minute, or 2.72 gallons per hour, which converts to roughly 65.17 gallons per day. My test water temperature and pressure were both on the lower end of Cloud's operating conditions spec sheet, and both temperature and pressure have a significant impact on RO membrane performance. It's also worth mentioning that flow rate matters much less with tank-based systems than it does with tankless ROs. When you turn on the faucet, you're drawing from purified water that's already stored in the 2.8 gallon tank, not waiting for water to flow through all 4 stages on demand. Still, flow rate tells you how long the tank does take to fill if it's ever completely emptied. Efficiency is one of Cloud's strongest categories, and it's where it really separates itself from other tank-based ROs. Most conventional RO systems typically have a pure to drain ratio of 1:4 or more, meaning that for every 1 gallon of purified water, at least 4 gallons are wasted. Cloud claims a 1:1 ratio, meaning only 1 gallon is wasted for each gallon purified. To test this, I unhooked the wastewater line and placed it in a measuring container, then turned the system on and collected purified water in a separate container while measuring the drain output. In my small draw test, I collected 12 ounces of purified water and measured 16 ounces of drain water. That works out to a pure to drain ratio of 0.75 to 1, meaning that for 0.75 ounces of water purified, 1 ounce went down the drain. The recovery rate, which is the percentage of incoming feed water that ends up as purified water, was 42.86% for that draw. I repeated the test with a larger 64-ounce draw, and the ratio improved to 0.97 to 1, with the recovery rate jumping to 49.23%. So at this larger draw, the pure to drain ratio was almost exactly the 1:1 that Cloud claims. And that improvement between the small and large draws is expected. RO systems tend to waste more water at startup, while pressures and flow stabilize across the membrane. Small draws capture more of that inefficient startup phase, while larger draws spend more time in steady state operation, which improves both the pure to drain ratio and the recovery rate. Because my incoming water pressure was on the lower side at 50 psi, I also tested the Cloud RO with an upstream booster pump to see how additional pressure affects efficiency. I repeated the 64-ounce draw test, and the results were impressive. The pure to drain ratio improved from 0.97 to 1 up to 1.56 to 1, meaning the system now produces more purified water than drain water, which is something I really typically only see with tankless RO systems. The recovery rate also improved significantly from 49.23% up to 60.98%, an increase of nearly 24%. Production rate jumped to 6.67 gallons per hour, which works out to roughly 160 gallons per day. And the energy use was notably low, about 0.001 kilowatt hours for the 64 ounces, which is roughly half of what I measured on other systems with the same pump. So if your incoming water pressure is less than 50 psi or it's on the cooler side, I definitely recommend considering a booster pump. I'll link to the Aquatech model that I used down in the description if you want to check it out. Across my 2 tap score tests with baseline TDS ranging from 76 to 707 ppm, Cloud RO reduced total dissolved solids by 82% to 90%, with higher removal rates on the more contaminated water source. I also wanted to see how the system handles TDS Creep, which I measured on site with my own handheld TDS meter. TDS creep happens when an RO system sits idle for a period of time, allowing pressure to equalize across the membrane, which raises the TDS in the initial draw of purified water after it's been sitting. For this test, my feed water measured 657 ppm TDS. I let the system sit idle for 10 hours overnight, then opened the faucet and measured the very first draw, which read 284 ppm. After running the faucet for 2 minutes, the steady state reading dropped to 68 ppm. That's a TDS creep of 216 ppm, which honestly really surprised me since this is typically really only an issue with tankless RO systems. Because I thought this was strange, I actually reached out and discussed it with the manufacturer, and they clarified that this actually isn't due to TDS creep at all. Rather, when a new cloud system sits overnight, the purified water sitting in the Remineralized filter becomes saturated with minerals from that filter, which is what causes that spike in TDS first thing in the morning. So this isn't true TDS creep from the RO membrane, but rather the intentional minerals leaching out of the Remineralized media into the purified water that's sitting in that filter cartridge while the unit sits unused. And this also explains why we saw the TDS reading stabilize to 68 ppm, as the first draw looked at a sample of the water that had been sitting in that filter, whereas the second stable draw showed us how the Remineralized filter affects TDS as the water has been flowing through it. So let's get into the lab data, which is arguably the most important part of any RO review. Like I already mentioned, I've now tested Cloud RO twice on 2 completely different municipal water supplies here in Colorado. My original 2024 test was conducted in Denver on a relatively clean municipal water supply with a baseline TDS of just 76 ppm. My recent retest was conducted with much more contaminated water with a baseline TDS of 707 ppm, almost 10 times higher than my original test water. For both tests, I sent pre-filter and post-filter samples to TapScore for laboratory analysis. And if you want to test your own water to see what's in it, I definitely recommend TapScore, which is hands down the best lab testing service I've found. I'll link to that in the description as well. The pre-filter samples came straight from my kitchen faucet, and post-filter samples were taken from Cloud's dedicated RO faucet after I'd conducted all my other on-site and usability tests. When I interpret TapScore results, I prefer to reference the Health Guideline Level, or HGL, which is the strictest benchmark and prioritizes long-term human health rather than meeting the federal MCL. Now, I'm mostly going to focus on the results from our retest for this video, though the results from both tests can be found in more detail on my website, which I'll link up as well. In our baseline water from the second test, TapScore detected a long list of contaminants with possible health effects. That included 3 disinfection byproducts above their respective HGLs, dibromochloromethane at 10.3 parts per billion, bromoform at 8.01 ppb, bromidichloromethane at 4.38 ppb. Uranium was also above the HGL at 0.0118 ppm and fluoride at 2.2 ppm. And several other contaminants were detected below the HGL, but still worth noting, including nitrate, nitrite, copper, total chromium, manganese, molybdenum, barium, boron, sulfate, strontium, and vanadium. Post-filtration, Cloud RO performed exactly like a good reverse osmosis system should. It completely eliminated all 3 disinfection byproducts: uranium, fluoride, copper, strontium, selenium, manganese, potassium, molybdenum, and nitrite, all reduced to below the lab's reporting limit. Barium was reduced by 97%, dropping from 0.0319 to 0.00068 ppm. Sulfate was reduced by 95%, dropping from 156 to 7.7 ppm. Total chromium was reduced by 93%, dropping from 0.003 to 0.0002 ppm. Overall TDS reduction in this test was 90%, which is right in line with what I'd expect from a well-functioning RO system. That said, there were 3 contaminants where the system fell a bit short. Nitrate was only reduced by 48%, from 2.5 ppm down to 1.3 ppm. That's lower than the 83 to 95% rejection I normally see, but in this batch of testing, several other RO systems struggled with nitrate too. This is most likely because my feed water temperature and pressure were both lower than ideal for the best RO performance. Boron was only reduced by 26.6%, from 0.41 to 0.3 ppm. And to be fair, this is expected. Boron slips through RO membranes pretty easily, and no residential RO system handles boron all that well. I saw similar results across every RO system I tested in this batch with this water. Vanadium was reduced by 50.7% from 0.00118 to 0.000582 ppm. It's possible that the Riemann filter is reintroducing tiny trace amounts of this metal, but it's still well below the HGL of 0.05 ppm, so not a concern at all. Now, just to recap the results from my original 2024 test on the cleaner water here as well. In that test, it also eliminated 2 disinfection byproducts, bromidichloromethane and chloroform, as well as aluminum, copper, fluoride, manganese, molybdenum, and strontium, and reduced barium by 78% and reduced sulfate by 94%. Reverse osmosis purifies water by removing almost everything, including the minerals and salts that give water a pleasant taste and contribute to its pH. That's why Cloud RO includes a built-in remineralization filter as the final stage, which adds trace calcium, magnesium, and sodium back to the water and elevates its pH. And the data shows the remineralization stage is doing its job. In my retest, feed water pH was 8, and post-filter pH measured 8.7 by the lab and 9 on my on-site pH meter. In my original 2024 test, feed water pH was 8.4 and post-filter pH measured 9.7 by the lab. Demineralized RO water without remineralization typically has a slightly acidic pH of around 6 to 6.5. So these data clearly show the remineralization filter is working to mitigate the effects of alkalinity and mineral loss. That said, it doesn't fully restore minerals to the same levels as they were in the source water. There's no reverse osmosis Riemann filter that can do that. What it does do is restore traces of minerals, alkalinity, and bring pH back up so it's no longer acidic. In this recent retest, calcium was reduced by 99%, magnesium by 69%, sodium by 92%, and potassium was reduced by 100% to below the reporting limit. In my original test, calcium was reduced by 93%, magnesium by 55%, sodium by 90%, and potassium by 100%. Alkalinity, which is a measure of the water's ability to neutralize acids, was reduced by 89% and 71% in tests 2 and 1 respectively. This is most heavily influenced by carbonate and bicarbonate. Bicarbonate was reduced by 89% in the second test and 83% in the first test. Carbonate was only reduced by 48% in the second test, yet in the first test actually increased 228%. This is what's mostly responsible for bringing the pH of the filtered water back up to alkaline. Now, I also tested chlorine on site. In my original 2024 test, I used chlorine test strips, which are not very precise. So in my recent retest, I used a handheld colorimeter for more accurate readings. Feed water chlorine measured 2.81 ppm, and post-filter chlorine measured 0 ppm, a 100% reduction in both tests. Now, talking about certification, Cloud RO is certified by the NSF to NSF ANSI standard 58 for TDS reduction. That also includes material safety and extraction testing certification as part of the same standard. And while NSF 58 for TDS reduction is arguably the most important cert for any RO system, this isn't the most impressive set of certifications I've seen. Cloud RO is currently only certified to reduce one of the 6 contaminants listed on its product page: lead, fluoride, PFAS, pesticides, pharmaceuticals, and TDS, which works out to about 16% of the manufacturer's overall reduction claims. That brought down the overall contaminant reduction score in my scoring system. TDS reduction is a great start since this tells us that the system greatly reduces all dissolved charged substances. Still, I'd like to see certifications for all the specific health contaminants they make claims about, especially PFAS and microplastics, which a TDS measurement can't accurately verify reduction for. That said, Cloud has communicated to me that they are pursuing additional certifications, so I'll be keeping my eye out for that over the coming months. Cloud RO has one of the most premium look and feel of any conventional RO I've tested. Right out of the box, everything is well presented with minimal plastic packaging, cloth bags for the small components, and far fewer loose pieces than you'd find in a typical conventional RO. The system is made from BPA-free food-grade plastic, and the dedicated faucet is lead-free stainless steel, available in 4 finishes. The 3-way cold water shutoff is stainless steel with a quick connect fitting for the tubing, which is a small detail, but points to higher overall quality. All 4 filters are housed inside a solid cassette that the company calls the magazine, so there are no flimsy components on the outside of the unit. The base of the unit houses the sensors and the permeate pump, and the tank stacks behind the unit instead of next to it, which means Cloud takes up significantly less space under the sink than most conventional ROs. Cloud RO has a mobile app that provides all kinds of data from its built-in sensors. The app tracks actual water consumption, tank volume, and individual filter lifespan. And here's something I haven't come across with any other water filter company. Cloud's customer support team can remotely enable a support mode on your app, which gives them access to all the specific data from your individual unit. That means if you're ever having an issue, they can pull up real-time data from your specific system and help you troubleshoot one-on-one based on your actual usage, water chemistry, and filter status. To my knowledge, no other water filter company offers this level of unit-specific customer support. Noise from the machine was essentially a non-issue. I measured 29 decibels at 1 foot away from the unit and 28.9 decibels at 3 feet away, and all you can really hear is when the intermittent permeate pump kicks on. Cloud's app and sensor-based filter tracking make maintenance about as easy as it gets for a conventional under-sink RO. The app shows the system's filter and battery status at a glance, and the sensors also give you a real-time reading of your water's TDS. And since the system tracks your actual usage and water quality, its filter life tracking and replacement recommendation is extremely accurate and not just based on a timer. Actually, swapping the filters is quick and easy, and you get a new battery pack along with the RO membrane replacement, so it doesn't add a separate ordering step. All right, let's talk about what I see as the main pros and cons, starting with the pros. First, and most importantly, Cloud RO delivered strong contaminant reduction across 2 very different water supplies. It eliminated the disinfection byproducts, uranium and fluoride, that were of most concern in my retest water, along with a long list of other heavy metals and inorganics. It's also NSF ANSI 58 certified for TDS reduction and materials safety. Installation was the fastest of any conventional under-sink RO I've tested, thanks to the pre-installed connections and smart cassette-based design. The app and sensor-based filter tracking make ongoing maintenance simple, and the support mode feature gives you a level of customer service I haven't seen from any other company. The 1-to-1 efficiency ratio is significantly better than the 1-to-4 you'd expect from most conventional ROs, and with a booster pump, that improves further to 1.56 to 1. The built-in remineralization filter raises pH and adds back trace minerals, and the overall build quality is more premium than most other conventional ROs that I've tested. As for the cons or drawbacks, there are really only a couple. Certification coverage is currently limited to TDS reduction, which is only about 16% of the contaminant reduction claims Cloud makes on its product page. The battery is not rechargeable and needs to be replaced with the filters. And upfront cost is on the higher end at around $550. scores. Alright, here's how Cloud scored in my data-driven scoring system and why it earned a 9.24 overall. For contaminant reduction, it scored a 9.42, which is the most heavily weighted category at 55% of the overall score. Cloud eliminated the contaminants of most concern in my water across both lab tests, but certification score was held back by the fact that it's only certified for TDS reduction, not the full range of contaminants the brand markets. For filtration rate, it scored an 8.5. My measured 65 GPD production rate was close to the manufacturer's 80 GPD rating, with the gap explained by my lower than ideal feed water temperature and pressure. For design, it scored a perfect 10. That breaks down into a 10 for component quality based on the premium materials, fit and finish, and overall build, and a 10 for material safety certification as part of its NSF 58 certification. For setup, it scored a 7.5. Even though it was the fastest conventional RO I've installed at 45 minutes, RO installation in general still requires DIY know-how and basic plumbing skills. For maintenance, it scored a perfect 10. That breaks down into a 10 for servicing requirements since the app and sensor-based tracking make filter changes simple and well-timed, and a 10 for ongoing cost at 18 cents per gallon. For company, it scored a 9.2. Cloud offers free shipping throughout the continental United States, a generous returns policy with a full money-back guarantee for 3 months, and 5-year warranty coverage on the unit. When all 6 categories are combined according to their weights, Cloud RO earned an overall 9.24, which is the highest score any conventional tank-based RO system I've tested has earned to date. So who would I recommend Cloud RO for? If you want a smart, modern iteration on a conventional tank-based RO with strong contaminant reduction, official NSF 58 certification, great efficiency and recovery rate, premium build quality, easy installation, and one of the best customer support experiences I've seen, Cloud is hands down one of the best options out there. And so who might want to skip it? If you need certifications for specific health contaminants like lead, PFAS, or chromium-6, you may want to wait until Cloud gets those certifications. Or look at other systems that already have certifications for the specific contaminants of concern in your water. And if you're on a tight budget and or don't care about the smart features, you can buy cheaper conventional ROs for less than half the price. Though it's good to also note that they tend to waste far more water and are much more involved when it comes to filter changes. If you want to see how Cloud RO compares to the other reverse osmosis systems I've tested, stick around and watch the next video coming up right now. Click or tap to keep watching.